Hello all, welcome to part 8 of the SecurityTube Metasploit Framework Expert course and certification. In this video, we will look at the STD API and the priv extensions and see how we can use them in post-exploitation. This video is part of the SecurityTube Metasploit Framework Expert course and certification. To enroll and for more details, please visit securitytube.net/smfe. Our certifications are being taken by students from over 30 plus countries around the world, so join the gang. And this video is provided free of charge as part of SecurityTube's vision to provide quality yet free InfoSec education to one and all. Okay, so in this video, we will look at collecting data, executing programs, and a couple of interesting things in the post-exploitation phase. So if we actually go back to our attacker machine, so we are already in a meterpreter session. If you do a quick question mark, at the very top, you have a couple of core commands. These are things like you can background the meterpreter session and stuff like that. And a couple of other interesting ones we'll take up later. Now, in Metasploit, in meterpreter, you can load extensions on demand. Now, the extensions which you have is STD API, which is loaded by default, and depending on the privilege level, even the priv extension can be loaded. You can load other extensions with the load command. You have a 64-bit as well as a 32-bit version, which is the default one. You have something else called Ispia, Incognito, LAN attacks, which we will look at in a separate video. So now let's look at how to use the STD API extension to our advantage. So if you scroll up, what you would notice is a lot of common tasks like listing the directory and all of that can be done using this. So let's say I do an ls. So this ls typically should happen on the remote machine, and tons of files simply because I'm in C drive Windows System 32. I could change my directory. Please note, all of these are STD API commands. Now my present working directory would be C drive. Again, do an ls to look at all the files. I've seen at times it fails, but you can just retry the command and it would work. You could even create directories remotely. Let's say near a directory called hacked, and if you notice, this directory was created here, right? You can verify this by going to my computer, C drive, and there it is, right? You have hacked here. Let's go inside hacked, and now let me remotely create a file inside it. So I'm changing directory inside hacked and say, hey, you just got hacked.txt. So echo will not work here directly. So what I can do is execute command.exe, hidden and channelized. May interact with this channel. Now I can do an echo command. Exit from here. But if we go back, you would notice that the hacked file has appeared. Now, using STD API, you can even upload and download files. So as an example, you can download a file or a directory by using the download command. So let's say download hack.txt, right? And this downloads the hack.txt file locally. You can even modify this file So this was modified on the attacker machine, and then upload this file back up. Now if you go on the victim machine, this would be the updated file with whatever changes which we had mentioned. Now there are a couple of other interesting things you can do as well, such as even edit a file remotely. So I could actually say edit hacked.txt, and this allows me to edit the file remotely, right? Now what you would see is that even though you had an error, the remote editing worked just fine. Now you could do a ton of other things like search for a specific file, delete a directory, and all of that. I'll leave these simpler commands to you. This is something we've already touched upon, and port forward is something we'll take up separately. So now let's understand a little bit more about the desktop systems on Windows to proceed further. So let me first get my UID, which is NT Authority System. And now let's understand Windows desktops. So Windows actually arranges desktops and all of that as different sessions. Now session 0 is typically the console session through which the logged in user is working. Session 1 and above are all remote desktop sessions. Now in each of these sessions there is only one interactive desktop called WinSTA0. All others are typically service desktops. Now WinSTA0 is basically the interactive Windows station which has three desktops. The first of which default is basically which the user interacts with when he logs in. Disconnect typically is the screensaver one, and WinLogon is when he's logging on to the computer. Please note that all of these three desktops have separate keyboard buffers. What this means is that if you go ahead and if you want to sniff on what the current user is typing in Notepad, you would have to associate yourself with WinSTA0 default. If you want to figure out what the user is typing in at logon, you would have to associate with WinSTA0 WinLogon desktop in order to do that. Let me show you an example. Now, STD API basically has three little interesting functions which allow you to do remote keystroke logging, right? So now I am system authority and I can look at my desktop by doing a get desktop. If you notice, this is nothing but a service desktop associated with session 0. Unfortunately, this will not allow us to do any keystroke monitoring, but let's prove it. So what we'll do is we'll do basically a key scan start command, and then we go back here on the remote computer and type something in. This is a demo, right? We go back to the attacker machine, actually do a keyscan underscore dump. And if you notice, we were not able to figure out any keystrokes, right? And let's stop this keyscan. The problem is we need to be associated with WinSTA0 default as the desktop. How do we do it? Tons of ways. The easiest is just to migrate to a process which has access to the WinSTA0 default desktop, which is explorer.exe, right? Found out the PID from here, 1896. Now if I do a get desktop, what you would notice is I'm associated with WinSTA0 default. Now let's start the key scanning once again. Go back here. The hacker can read this remotely. Now I go back here, do a key scan dump, and if you notice, you can now read what the victim was typing remotely, right? Fantastic. So the key thing to remember here is if you want to do keystroke logging or take screenshots and all of that, you need to be associated with the proper desktop before you can do it. So as an example, if I want to do a remote screenshot, I can just basically do a screenshot command. This takes the remote screenshot and stores it locally into a file, an image file, and if you notice, this is exactly what was there on the victim machine, right? Fantastic. Now, a couple of other things which I want to touch upon is the priv commands. This allows you to do a lot of interesting things. We've already looked at get system. One of the others is called hash dump, which actually allows you to dump all the hashes in the SAM database, right? So these are the different user accounts and the different hashes which have been dumped, which you can use with various password cracking tools in order to crack the exact password used in these accounts. Now similarly, there is one interesting thing which you can do with priv, which is change the timestamps of file arbitrarily. So this is done using the timestamp script. So timestamp allows you to change the time arbitrarily. So what I'm going to do is I'm basically there in the desktop right now, not in the desktop. So I'm going to just change to my hack directory once again. Right, where I have hack.txt, and now I'm going to change the timestamp of hack.txt so that the admin does not figure out that something went wrong. Now I never seem to remember the syntax of timestamp, so I'm probably going to stumble a little bit here. Timestamp hack.txt. Let's change all the 4 attributes. 01, 01, 01, and then to 112020. I'm very sure my format is wrong. It is. It's actually just the opposite of what I did. Sorry. Right, and then hours and minutes. There you go. And if now we actually go back, so what I've done is I've changed the date to 2022, which is the file is from the future. Let me kind of go back here. And look at the properties. And if you see, the created and modified TAM both have been changed. Accessed will always reflect the last time you touched the file. But if you just leave the file as is, basically the different parameters would be appropriately set. So the best part about timestamp is that once an attacker wants to leave some files and change that timestamp to match some of the system files, it is extremely easy to go ahead and do that using the timestamp utility. Now you can even remotely look at the values for any given file by just doing the -v option, right? Which is exactly what we did right now. So the maze parameters modifies, access, created, and entry modified all point to 2022, right? So you can do a ton of other interesting things Have a look at STD API and Priv. I have covered most of the interesting ones, and as I said, Metasploit is always evolving, so you may find newer things which keep coming. Have a look at them. Going back to the PPT. So this is what I had in mind. We'll look at tokens and all of that in a later video. So this was part of the SecurityTube Metasploit Framework Expert video series. Check us out at securitytube.net/smfe, and thank you very much for viewing this video.